We want to find an equation of a polynomial function with the real coefficients having zeros negative 2/3, 3/7, and negative 1. Remember, having these zeros of the polynomial function gives us information about the factors of the polynomial functions. So for a quick review, we know these zeros are the x values for which the function is equal to 0. If our zeros or roots are r sub 1, r sub 2, r sub 3, and so on, then the polynomial function must have a factor of x minus r sub 1, x minus r sub 2, and x minus r sub 3. Notice these factors are x minus the known zeros. Also notice we can put a constant here, and it would not affect the zeros of the polynomial function. And because our given zeros are fractions, we will have a constant because we normally don't want fractions as coefficients in the polynomial function. So again, going back to our example, if these are the known zeros, then our function f of x would have to have a factor of x minus negative 2/3, which we can write as x plus 2/3. It would also have a factor of x minus positive 3/7. It would also have a factor of x minus negative 1, or x plus 1. One more thing to notice here, if the zeros are negative, notice how the factors contain a sum, and if the zero is positive, the factor contains a difference. But we don't want to leave the polynomial in this form because we don't want to work with the fractions in our factors. We can clear this fraction of 2/3 by multiplying this factor by a constant of 3, which you notice again is a denominator. We can clear the fractions from the second factor by multiplying by a factor of 7. Again, notice 7 is the denominator of the fraction. And since 3 times 7 is equal to 21, if we go back to the previous slide, our value of a would be 21. But we're not going to write it in this form because we actually want to clear these fractions. So now we're going to distribute here and distribute here. So we'll have f of x equals, the first factor would now be 3x and then plus 2. Notice how the 3 here and the 3 here simplify out. The second factor would now be 7x minus 3. Again, notice how the 7 simplify out here, and our last factor is still x plus 1. Now if you can actually go straight from having these zeros here to these factors here, that's great, it'll save you some time. Another way to come up with this factor here, knowing the 0 is negative 2/3, we can say we know x equals negative 2/3 is a 0. If we multiply both sides of this equation by 3, we would have 3x equals negative 2. If we add 2 to both sides, we would have 3x plus 2 equals 0. Therefore, 3x plus 2 would have to be a factor. And the same thing for x equals 3/7. Knowing this is a 0, we could multiply both sides by 7. That would give us 7x equals 3, subtract 3, and we have 7x minus 3 equals 0. So 7x minus 3 would have to be a factor. So there are several ways to come up with a factor that doesn't contain fractions when our 0 is a fraction. So now we're going to multiply this out, 2 factors at a time, to find our polynomial function. So multiplying these first two binomials, we'll have 4 products, 1, 2, 3, and 4. So we'll have f of x equals 3x times 7x is 21x squared. 3x times negative 3 is negative 9x, so minus 9x. And then 2 times 7x would be 14x, so plus 14x. And then we have 2 times negative 3, or minus 6, times the quantity x plus 1. Let's simplify this. We have two like terms. F of x equals 21x squared. Negative 9x plus 14x is plus 5x. Minus 6 times the quantity x plus 1. Now we'll have 6 products. 1, 2, 3, 4, 5, and 6. So we'll have f of x equals 21x squared times x, that's 21x cubed, 21x squared times 1 plus 21x squared, 5x times x, that's plus 5x squared, 5x times 1, that's plus 5x, and then we have negative 6 times x, that's negative 6x, so we can write minus 6x, and then negative 6 times positive 1, that's negative 6 or minus 6. Last step, we'll combine our like terms. We have two x squared terms, and we have two x terms. So f of x equals 21x cubed. This would be plus 26x squared. 5x minus 6x is negative 1x, or minus x, minus 6. This would be a possible polynomial function or cubic function that has the given zeros. And again, to verify this graphically, if we graph the function we found, the zeros should be the x-intercepts. Notice how we have an x-intercept of negative 1. This looks like negative 2/3. And this looks like positive 3/7. It's a little bit more difficult to verify it graphically when we have fractional zeros, but I think it's still worth graphing it to check. I hope this was helpful.